So we're recording now, and maybe I'll just kind of quickly introduce myself if you want to introduce yourself. So my name is Chris, and I'm the founder of Vibehut. Vibehut is a Web 2 and Web 3 video call network state platform, and we've been working on it for about 2 years, and it's been used by people in around 155 countries so far. Thanks so much for joining me, Cassie, and I'm really excited to kind of talk to you about some of the projects that you've been working on recently.
Yeah, thanks for having me. I'm Cassandra Hart. I'm the founder of Quilibrium Inc. Our project is a peer-to-peer decentralized MPC platform as a service. That's a lot of different acronyms. So easier to think of it as a new layer 1 protocol for building web applications.
Okay. And then that's really interesting. So what do you think kind of separates your layer 1 from other layer 1s? And we can kind of get into some of your projects shortly, but just for the audience that may or may not have heard your, I guess the layer 1 MVC kind of framework that you have, maybe a little bit more detail would be good.
Yeah, the technological underpinnings get pretty complex, but what we do well is that we actually make a lot of that complexity invisible to the end user. And the end user, in our point of view, of course, is the developers. So for what we do with our project, it's basically trying to give the same kind of AWS style experience, but with some of the value adds that exist in crypto, which is the obviously tokenizability of assets, being able to run things in a completely decentralized context, those types of powerful primitives. But on top of it all, because it is MPC based, it gives one thing that a lot of other layer 1s can't do, which is complete privacy. In other words, the assets that you hold, the code you've deployed, the applications that you run, the users that are using those applications, that data remains completely private to only the people who are authorized to access that data.
That's really interesting. And so I guess would you consider that kind of in the ZK realm in terms of the privacy aspect? And do you involve yourselves in those types of communities when you're kind of talking about it, or is that kind of a separate, I guess, vein of the kind of crypto and cryptography?
So you can actually kind of think of it more of a Venn diagram, because there's 2 different fields, or I guess subfields, if you will, in cryptography, where you have the multi-party computation aspect, where inputs are private, but outputs are public. And then you also have the zero knowledge proof domain, which the inputs and the outputs are private. It's essentially just a output that proves that whatever you are trying to assert to be true is true or not. Where they actually intersect is that you can create these constructions that are MPC based that produce an output that is still private. And so the various types of MPC protocols that exist do enable a way to essentially construct zero knowledge proofs without revealing the output data and provide that same kind of proof structure. So it's not that they're completely separate, it's just that they do sort of different things and at the same time can sometimes do the same thing.
Yeah, totally. And I guess from a like just a culmination point of view, having these different primitives allows app developers to build whatever platform that they'd like. And so it's kind of like if you don't have it, then there's a whole subset of projects that are either impossible or far harder to do unless they have something like your framework or your blockchain. So what, in terms of the kind of, I'd love to kind of get into the applications that you find particularly interesting these days. And then maybe, so are there kind of some examples that come to mind where when people ask you saying like, okay, well, where is it best used? Or if I was to start a project right now, when would I start to consider Quilibrium?
So it's kind of a complicated question, and the only reason I say that it's a complicated question is because the goal of Quilibrium is to secure every bit of traffic over the internet. Like that's our big, hairy, audacious goal.
Right.
And so when people ask that question, it's kind of like also saying, when would I use AWS? And the answer is, well, there's lots of reasons you'd use AWS. Yes. And so there's a lot of different applications that can be built on it that can't be built on other layer 1s. a lot of that comes down to certain considerations like speed. Obviously, there's very few networks that can offer a transaction per second throughput that's just fast enough to accommodate, very large data applications. There's cost. For example, Solana is faster in TPS when it's running, and that TPS is great, but the cost of data is very expensive on Solana. So then you have like these interesting Frankenstein models of like, you got layer 2s that have cheaper gas, that have data availability proofs that go up to the L1, and then you have like a data availability layer at a layer 0, and all this kind of like Frankenstein nonsense that is incredibly complex, ultimately very fragile, and for a developer experience is just nightmarish. There's so many foot guns involved, and as we've seen so many times, so many different hacks at either bridges or just like reentrancy bugs because the EVM is kind of a nightmare to debug and code for. These are just problems that happen because of a consequence of the architecture that exists in the prior models of building distributed peer-to-peer architectures like blockchains. Quilibrium is actually not a blockchain. Quilibrium has a different data consensus model that gives a much greater degree of throughput and also a much faster time to resolution. Blockchains are probabilistic. So in other words, when you have like traditional Nakamoto style consensus, like you have just a blockchain, like the Bitcoin blockchain, every 10 minutes a new block is issued, and it's based on reaching that difficulty bar with a hashing algorithm. That's all cool and good, but you don't actually consider a transaction finalized until there's been sufficient length past that point on the chain before statistically it is highly improbable that there will be a chain reorg. We actually have invented a way to do single slot finality such that it is guaranteed that when that executor executes that data and broadcasts that frame of data to the network, it is now considered finalized and complete. So you can implicitly trust that the data has been stored and is replicated successfully. And so that alone is already pretty groundbreaking, but we do this in a completely shard-based fashion that spans out to an addressable space greater than the number of atoms in the universe in terms of the number of bits that we could potentially store.
Wow. Yeah. So it's all so technical, right? And so one of the things about being so in the weeds and kind of, I don't know how kind of, I guess, consumer facing you guys feel, or you might be largely talking to the eng teams at these companies and kind of you're selling at eng conferences or I guess in addition to the technology, I guess this is more of a business side question, but like when you develop something like Quilibrium, how do you approach marketing and how do you approach kind of tackling adoption of your data consensus model?
So that's the thing that's the most valuable aspect. We don't have to talk about that at all. Instead, what we can do is actually expose the interface to the network instead. We actually abstract that complexity away so far that you can think of it like this. Amazon Web Services, for example, is at its core a very massive collection of data centers that are running virtualization software on their racks of data centers with varying degrees of replication capabilities, hot swapping, all sorts of typical server maintenance stuff. But the end users, say you're using AWS Lambda, you're not thinking about that at all. You're just writing code, you deploy it as a Lambda, it does whatever magic it needs to behind the scenes in order to execute that Lambda and give you the result you want. And that's the same way that we approach the design of Q. So instead of building applications that you have to really internalize the state thereof, like, for example, if you're developing for Ethereum, for better or worse, you have to understand the EVM or else you're going to get burnt. We designed this in an entirely different strategy. From the very core principle, it was a kind of how Steve Ballmer had that very infamous developers thing. That is the same kind of thing we did. We took the approach of build tools that developers know how to use already. And so by doing that, we created a compiler that takes simple Golang applications and can run it. So from the perspective of somebody who's developing software in the same way that they've done in the Web 2 world, it's actually very easy to just copy paste code and run it on Q. And so by giving the primitives that developers already understand, especially when the API surface area actually just outright uses the same API surface area that Amazon's using, it becomes practically a no-brainer for them. Like they can just simply lift and shift. And so that's a huge unlock.
Yeah, I agree. I think that it's almost what happened with like SOAP APIs and the REST APIs came in, and it just unlocked developer access to all of these data stores that traditionally they didn't have access to. And it was in this kind of familiar protocol where it's kind of like, okay, well, I know how to write a get request or post request. And it's like, okay, if I can do, and do you guys support other languages other than Go, or is it primarily Go that you like to focus on? Or
I mean, right
obviously
now,
it's a spectrum, right? It takes time to develop it.
So, I mean, at the end of the day, technically we could support any compiled language that is deterministic in nature. What we're doing right now is just simply Go. But technically, the way that this compiler architecture is built, we could support other languages. It's just the reason we chose Go is because there's a lot of developers in the space that are already very familiar, comfortable with Go, built a lot of tooling for Go. And another thing to really consider is that we're not going to capture a lot of Web 2 customers outright immediately, but we can capture a lot of people who are using, say, for example, Ethereum, where there's a lot of Go-oriented solutions. And that actually can create some very powerful value adds, even if they're still in the EVM world, because what Quilibrium enables with the ability to do multi-party computation is a way that they can use it as a substrate for secure computation of things like private keys. So for example, you have all of these MPC wallet as a service providers. And a lot of these MPC wallet as a service providers, I'm going to be frank, they're lying. They're not actually doing real MPC. What they're really doing behind the scenes, there's a few that are doing the real thing. Zengo, Coinbase, I'll give them a big shout out. They're doing the real thing. But there's a few out there that are not. What they do is they will do what is called a Shamir split. Basically, you can really think of it as taking a key and just breaking it in two and giving it to two parties or more. And behind the scenes, what happens is when you make a request through these APIs, you as a user have your key on your phone, you send that key shard to their secure enclave, which then can hold on to that data like that. The only place that data is exposed is inside their secure enclave that they are essentially promising to you that they will never read. And then they recombine in that enclave, perform the signing operation, give you the signature, and then erase all memory. And that's not real MPC. And so what Quilibrium offers is a way to actually take that type of real MPC, the things that allow you to do threshold signing or more advanced computation like private set intersection protocols, where you have multiple parties that do not want to share all of their data with one another, but do want to do something like, like for example, in the business world, you have accounts receivable and accounts payable departments. They gotta make sure their books are aligned, but they're not going to give each other their books. Like that's immediately a non-starter for business. So instead, what you do is you create a Switzerland of data that has advanced compute capabilities, but you can just write it in simple Go. And that alone is like a completely new generational unlock on top of just being able to deliver the same AWS style services that existed before.
Yeah, I love that. I think that to be honest, for everyone listening and just the kind of taking the technical and saying like, look, like we are going to create the Switzerland of data, and then there's different ways to access it. Really kind of helps simplify and helps people understand it. One thing in the kind of the ZK world that kind of was an unlock for me, or was always interesting to me, was if you take modern day, like when you walk into a bar and you might pay $50 to get into the bar, $20 to get into the bar, depending kind of where you are. But when you walk into the bar, it's not normal to kind of have your bank account showing on your chest and be like, hey, like this is how much I'm worth, right? And a lot of these kind of cryptography solutions are providing something almost like what resembles how the real world works, but just through code, right? Where it's like when you go into Vibehut's a good example, where it's if you have a video call, we can make it so you own an NFT to get access to that video call. And so that's one level of it. But if you own all of your NFTs in one wallet, we are still going to say like, hey, you have all of those NFTs. And so somebody can look up your wallet address and be like, hey, this person I'm talking to has, I don't know, $20 million worth of NFTs. now they have a new type of risk associated with the conversation where it's like they have just kind of exposed their entire bank account or their Web3 account, because a lot of people are just running around with a single kind of wallet identity. The smart people are kind of separating stuff like that, but it can get very heavy. So I can certainly see the need for all like Quilibrium, the model that you're talking about in terms of the access to data, and then really it's so configured. It sounds like it's extremely configurable in the sense that it is really up to the developers to decide kind of what data is going to be private, what's going to be public, and then it's just kind of like a recipe in an ingredient. It's like, okay, well, we can do all sorts of configurations. So it really just depends on the scenario. And sometimes it's hard to kind of, it's funny. I asked you the question earlier, being like, okay, well, where would you use this? And you're like, well, to be honest, our big goal is it's going to be used everywhere. It's going to be used like, where is it not going to use is probably an easier question to answer. I guess there's two other things that I really wanted to kind of run by you is that, what is one example that you really like so far that you're like, you know what, that's, if I have to tell somebody about it, like that's really cool or it's very novel. And then I would love to kind of talk about your doom in frame after and kind of wrap it up after that.
Yeah, so I'll actually give you three different answers to it, because there's a crypto perspective that's valuable. There's a performance perspective that's valuable, and then there's a social perspective that's really valuable. Mm-hmm. And so from the crypto perspective, there's obviously the notion of everything being private by default is something that is a major breakaway from a lot of the current public ledgers. That's something that alone a lot of people can see a value add to, but there's the consequence that historically these privacy coins have been largely adopted by bad actors. Part of that has to do with it being largely because they're slow. And so who would put up with the slowness is the people who feel like they really need privacy for whatever reason. And so tends to get used for all the wrong reasons. But Quilibrium's fast. So there's the advantage that it's actually a usable network and it's private. But on top,
actually, just to jump in there, when you say it's fast, how do you measure the speed? Is it by TPS, or is there another metric that you guys like to kind of point to?
So TPS is a little complicated because TPS is in a, for example, in a Bitcoin context, transactions are, I wouldn't say they're perfectly uniform, but you can get a good baseline for transactions per second based on the size of the transaction, averaging around, I think it's like 250 virtual bytes and a dedicated one virtual mega virtual byte of space per block. And so divide that out and you get roughly about 7 transactions per second. Ethereum, you have a different, method there because you have a gas block limit or a gas per block limit. And so there's varying metrics that you can use to measure transactions per second, but all of those, even Solana, for example, which is known to have an incredibly high transaction per second rate compared to others, at least when it's running, there's this notion of transactions per second, but it's in the context of this all being strictly linearized blocks. They're all just, they're a blockchain. And Quilibrium is not a blockchain. Quilibrium is something very different structurally. I call it a time reel. That's actually hearkening back to the original days of Bitcoin. Satoshi did not originally call it a blockchain. Structurally, Satoshi called it a blockchain as 2 separate words, referring to the blocks of transactions. But when actually referring structurally and semantically to the network, Satoshi called it a time chain. And that actually is kind of a, seeking backwards, I'm kind of making a reference there. We are doing what is a time reel. We capture a stream of events of sequential data, and then from the stream of events of sequential data that is unforgeably true, we actually have many, many, many shards, not infinitely many, but certainly more than we will ever actually fill out for the time that I'm alive in terms of the total addressable shards that can exist. And from those shards individually, we have roughly a throughput of about 50 million operations per second. Now, 50 million operations per second, you can kind of compare to, for example, Ethereum right now, it has a maximum of, I think it's 30 million gas per block, which is, that comes down to like what, maybe 150 operations tops. I don't know. It's that's kind of a harder comparison to make because we're doing actual bit operations per second. They're doing something else that's actually like hard coded. But that's a good comparison. Like we have a clock speed of about 50 megahertz, but it's 50 megahertz processors that are spread across literally beyond trillions of possible units of compute at the same time.
Gotcha. And then one thing I'm sure people closer to your model know, but in terms of upgrading, so can you constantly upgrade it, or is it something like do you version control this time rail, or how does that work if you want to kind of go through that upgrade cycle?
As somebody who's been around for a very long time in the crypto industry, there is one truth that has been a constant theme, which is nothing ever stays secure forever. And so because of that, every single cryptographic component that is baked into Q, every single sort of like structured protocol component, like rather than being something that's cryptographic, but it's actually just like logically based, all of that is individually versioned components that are swappable at any time based on network upgrades. Obviously, those upgrades need to happen at certain intervals, but fortunately for us, our core global consensus is structured around a sequencing of events that is unforgeably valid.
It sounds perfect. Okay, so of those, we had speed. What was the first one again? You said there's three of them. There's three examples.
The first was cryptography related, the cryptocurrency scene related. The second was performance related in the sense that there's a significant amount of speed improvement. And then finally, third, the social one. One of the things that like we can already inherently see value in our day and age, because we do everything over HTTPS now, there's people who try to intercept communications. We use Signal or Telegram secret chats to actually or make our conversations private. These are things that we inherently value. But what we haven't fully translated that value into is the privacy of full systems. So for example, there is one particular project that I'm working with that I will be announcing at FarCon that has a very good reason, socially speaking, that literally their goal is with respect to saving lives. And part of that process of ensuring these lives are saved requires data to be private for a duration prior until that actual rescue can happen. And so that is something inherently valuable. And no other crypto network is able to deliver that type of censorship resistance and privacy preservation. And so that is instantly a new category of types of applications that can be built that no other platform exists for.
Gotcha. And then how do you guys, I guess this is kind of, again, flipping back to the business side, but how do you guys earn or stay afloat, or how does this whole thing get funded, I guess? Because obviously you guys have an extremely talented technical team, and all this can't be kind of for nothing. But just how does that work, or how do you guys think about that?
So I'm gonna answer this question delicately. There's obviously some legal considerations to how that question can get answered. So I just want to say that without sounding like I'm trying to dodge the question here. It's just that there are reasons why I have to answer this carefully. But speaking from a protocol level, there is a network token. That network token is a purely fair launch token. So from the perspective of doing this protocol launch, we just like even the time reel is a nod to the time chain. We took the same idea of Bitcoin's fair launch and did a fair launch ourselves. And so the network's token distribution is purely based on people who are operating nodes. And so from the perspective of Quilibrium Inc., the company that I founded, Quilibrium Inc. operates very few nodes in comparison to the overall scale of the network. We actually already have over 26,000 active nodes. And that, I mean, still astounds me. I have no idea how that happened so quickly, but it did. And so by consequence, we run a very small portion of nodes, and we don't actually gain a lot of tokens from that. So from that perspective, we do not think about the inherent value of the token, because to us, the token is strictly a utility. From the perspective of the company and how revenue can be accumulated at the company level, because obviously a company's goal is to make money, our goal is to provide AWS-style managed services that run on this network and bill for those services. So we have this very like actual traditional Web 2 almost SaaS model that is like intersecting with the entire like Web 3 world that exists. But it gives you all of those advantages of Web 3 with something that, you know, regular businesses can actually understand, adopt, and make sense out of.
Yeah, you know, so I guess I've been in business for a while, and software. And one of the things that was always very interesting to me, actually, I have this very sharp example in my mind, but Redis, which is, I'm sure you're familiar with Redis, as most people are, but Redis came out as open source, and I was always like, what a great product to be open source. Like, thank you so much for creating such a great product and great code. And so I was using it in a lot of my projects, and what turned up is effectively the model that you're explaining, and it's really kind of either you're a hosting provider or a consultant, and that's kind of where the or like a managed service provider or a consultant, and those are the two ways that a lot of these open source projects are going from being fully open source, and obviously the technology is very distributed, but the revenue capture is actually happening is actually in this kind of this hosting portion or the consulting portion. So there's just a very strong parallel between what I saw with Redis and what we see with Quilibrium, which I think is a very reasonable model, right? Because the technology is just going to keep improving, and really it is a shared thing, right? There's all sorts of developers that are contributing to it, whether they're contributing as node operators or kind of just contributing their brain share to the kind of data consensus. So it's like, okay, we can all use that. And then I guess there is this kind of natural, it's interesting to watch actually, because the people that are closest to it end up kind of capturing a big piece of the pie because they're the best ones to kind of provide suggestions and things like that. So even we see it right now, Facebook's doing the same thing with Llama, right? Where they open up this Llama model, Llama 3 or Llama 2 or whatever, wherever we're at now. And they open it up, but again, they are kind of hosting it at the largest scale. And so that's really where they're collecting. And from a technology point of view, it's in a business point of view, it's always been interesting because it's like, usually we think about things where it's like you create something and then you sell that thing. But it's actually a second step removed where it's like you create the thing with a group of people you created, and then you actually just help support it actually exist and kind of maintain it and provide insights to all of the businesses that are not using the service to saying like, hey, look, you could use this and it's going to reduce your costs, or you're going to get better throughput in your business, or it's going to be more private or more secure, et cetera, et cetera, et cetera. So it's a little bit of a tangent, but I really think that model, it seems to be a very compelling model for a lot of these projects that we continue to see kind of pop up and saying like, well, where does it make money? It's like, well, it makes money with all of the additional service that's associated with it.
Yeah, and there's one thing that I actually want to call out real quick about the mention originally of Redis. There is a phenomenon that tends to happen in open source projects, especially very large open source projects. You've got Elasticache, you've got MongoDB, you've got like practically all of HashiCorp's products. They all had an open source license. And then they reached a point where, of course, there were other companies that were stealing their lunch, so to speak, and they decided to move to a shared source but proprietary license, or at least questionably proprietary license. I've got my own opinions about MongoDB's license, but nevertheless, people will conventionally agree it is not a standard open source license. What we have done for Quilibrium is that we are doing an open source license. We are doing the AGPL. And very specifically, we have a declared intention around the way that we interpret the AGPL. Because one of the fundamental goals of Quilibrium, and one of the things that drives me every day, and this is going to sound incredibly wild, but I want to kill AWS. I want to completely dominate AWS.
Jeff.
Google Cloud Platform, Azure, all of them, because all of these companies are in, they have access to your infrastructure. And while there is a trust component that they will never break that trust, there is also a very real phenomenon that was exposed by Edward Snowden that sometimes that trust gets broken and you will never know. And so from the perspective of Quilibrium, our goal is to secure every bit of the web. And part of that means that we have to defeat the infrastructure cloud providers of the current day and replace it with a decentralized cloud alternative. But as the natural course of business, that then raises a risk in the future of the company, that the future of the company, perhaps either through the amount of shareholders that have control or whatever, that there may be a position in the future that they would want to turn into a direction in the same way that MongoDB has or any of those others. And so we were very clear in the license that we are essentially creating a very infectious license. This license is interpreted such that if a company were to adopt Quilibrium, not as a platform to use to launch your product, but like to basically clone Quilibrium. Like if AWS were to clone the repository and then build their own managed Quilibrium instances of their own, this license infects backwards into the company, and they would have to expose all of their management infrastructure tooling that is used to do so. So they never will. And that same type of license proposition exists for Quilibrium Inc. So that way, our own company will forever be limited by that same exact notion, so that it's not a, how Google used to have the phrase, don't be evil. It is very much the can't be evil.
Can't be evil. Yeah. I mean, I'm very impressed as we've been kind of talking this whole time about the your ability to be so intentional and so thoughtful of kind of the world as is, and kind of the world that you would like to see exist, and the edge cases as sharp programmers would. But I think that you're even on a level that you are kind of bridging the gap between not only the technology side, but then also the real world or the business side as well, in terms of like, okay, well, not only are we going to create this technology, but how can our technology be used? I just find that very impressive in general. The last point that I want to go through is, I guess, the original intent of me reaching out to begin with was, and maybe a little bit more fun and lighthearted, is I guess you've been building a couple frames, or you're familiar with the frame specification, and it seems like you're able to kind of get Doom into a frame. And I was wondering kind of if you just want to talk about that, where that came from, what are you continuing to kind of build those things, or is it kind of just a pet project, or everything kind of around that I'm very interested in. So maybe if you just want to start kind of a little bit about your background and kind of Warpcast and how you got into frames, and then we can kind of talk about kind of where you see frames going and stuff like that.
Yeah, so full upfront disclosure, I also still work for the Farcaster team. So I have a little bit of extra insight that frames were coming.
Yeah.
But that being said, I wanted to also set this as a challenge for myself. I feel very, like, if it wasn't obvious from the way that I approach things in life, I feel very strongly about this idea of fairness and never violating that fairness principle. And so by virtue of doing so, I refused to actually do any work towards implementing a frame until that was publicly available to everybody. And so one of the first things that happened, like right after frames were revealed, the CTO over at Paradigm had posted a cast saying, all right, who's going to be the first person to put Doom in a frame? And for me, as somebody who's been building Quilibrium for literally over 6 years now, one of our internal technologies that we're going to be releasing later on, as this company goes along, is a meta virtualization machine. And essentially what that is it's basically an instruction set architecture reinterpreter, such that you're able to take a target ISA set, bring it into the MetaVM ISA, and then execute it. And so that's a powerful primitive. And for us, you can kind of think of it like QEMU or KVM or any of the other major tools that a lot of people will use. And so for us, it was like, okay, I have the MetaVM already. I have already been able to run Linux on this. I've already been able to run Doom on Linux on this. So all I need to do is just glue this in to basically that frame, OG tag format. Can't be that hard, right? Well, then I realized there's one little catch. In frames, there's no video support. So naturally, I wanted there to be video support. I didn't want to have people click buttons to see screen updates. And so I was just thinking for about 30 minutes or so, and I remembered back in the day, I used to work for a telecom. Basically, they provided soft switches for telecoms. Is kind of quirky little consequence of the big Ma Bell split up. Anyway, one of the things that we offered to customers was home security cameras. And I developed the tooling for those home security cameras because the default ones that Linksys provided was garbage. And so one of the things that I found out during that time is the way that they actually provided that video stream was before streaming video was commonplace enough that most browsers supported it. So what they used was this technology called MJPEG. And MJPEG is literally just chunked content streaming HTTP data. So basically just an open HTTP connection that never terminates, at least until the server chooses to terminate it. And it sends multi-part chunks, just like multi-part form chunks get sent to the server, but in the opposite direction. And it's just JPEGs, just repeated streams of JPEGs. So very bandwidth intensive, which is why it's usually constrained to LANs. But I was like, it can't be that bad. I'll foot the bill for it. And so I basically cut a canvas that the MetaVM could render Doom to, and then pipe that canvas into a JPEG conversion and feed it back out as a frame. And then as a kicker to demonstrate how well this could tolerate multiple people all interacting with this at the exact same time, I made it one instance of Doom. So everyone was playing the exact same instance of Doom together and let chaos ensue.
Yeah, I honestly think it's really brilliant. And do you know like how many people ended up playing, or and then I guess on the performance side, is there something like an FPS that you're able to get up to, like 30 FPS, 60 FPS, or anything like that, or how did it play out?
So I originally did 60 FPS. It was just fine with it. It could handle it just fine. What I couldn't handle just fine was how much bandwidth that consumed. So after seeing it tear through over 100 terabytes of bandwidth, I had to trim that down to a nice 10 frames per second. But ultimately, I couldn't say for sure how many people all played all together, because one of the principles I have behind Quilibrium is that I value anonymity strongly, so I don't keep logs. So I couldn't tell you how many people played it simultaneously, but I could tell you enough people played it simultaneously to generate over 100 terabytes of traffic.
Yeah, you saw the bill. The bill was enough.
The bill was enough.
And then I guess one of the reasons that I guess I find it interesting is being the founder of Vibehut, which is a video call platform. I guess I'm very curious to see, do you think that there's a cheaper way to do it, or a way for video to be kind of streamed in frame to Warpcast that is a little bit more, I guess, cost efficient?
I will predicate this answer on a technologically, this is how it would be done to do it. This is not an answer of whether or not, Warpcast will support this or Farcaster will do this, because obviously I cannot make product announcements ahead of time, nor do I. But I mean, theoretically, yes, it could be very well possible to do it. You would just need to simply have a stream URL to point to. One of the things that we do have to keep in mind that is an important consideration, because while, obviously Warpcast is a public social network, so there's a lot more public data and analytics that you could, aggregate out of that, users are obviously opting into it by virtue of using the service. There's still a little bit of a privacy component that people have to think about, and that when you interact with a frame, you're actually interacting with the Warpcast servers so that it can generate the appropriate frame request and then direct it to the provider of the frame, which is at a different, domain, URL, etc. When we first launched it, that wasn't actually the case. They would actually construct the request and send it directly to that URL, which meant that anybody who interacted with a frame was revealing their IP address. And obviously that was not an ideal situation, but there were very few frames that were created at that point. And frankly, it was kind of an honor system. So we moved away from that very quickly. We started proxying requests through. But the consequence of proxying requests through means that now we also have to be responsible for the bandwidth of all the data that's channeling through. So realistically, were Warpcast or the Farcaster protocol at large to support frames in a way that would allow streaming video, because I'd love for that to happen so that I could revive the Doom frame to 60 FPS.
Frames are bad, yeah.
There would need to be some sort of reasonable intermediary proxy that can still preserve privacy of the end users. Obviously, the purpose of Quilibrium is to be an anonymizing proxy at the outer shell layer of the network. So, I would be more than happy to facilitate that, but that is way out of scope, way out of discussion, and just entirely theoretical in nature.
Yeah. I empathize with all of that. The fact that the proxy will kind of the Warpcast kind of team would have to shoulder the cost of that proxy, but then also the benefits of having that proxy with anonymity, kind of masking the IP addresses is certainly beneficial as well. But I think that maybe the conversation remains open, always open to discussion, always willing to chat about it, and if somebody wants to kind of explore it or kind of discuss it further, where the Warpcast team alone right now has so many priorities on their backlog, I'm sure they're overflowing with asks and requests. So, but I think that just them knowing, or I guess you guys knowing, that there's certainly some groups of people that are interested in talking about it and are able to talk about it in a kind of mild manner approach is, I think, important.
And not only that, but the beautiful factor about all of this is that Farcast is a decentralized open source protocol. So if the community were to fork the Farcast or hub repository, add support for such a thing, and it was the majority adopted hub behavior, then that fork essentially is setting the standard. Whether or not that would happen, I don't know, but it is certainly a real possibility. Forks have happened in networks before.
Yeah, totally. Yeah, forks are. Yeah, it's a great way to kind of keep everyone kind of pushing forward and kind of open to proper new kind of avenues of the river. Just kind of saying where could we go, and if there's enough demand for it, then it makes a lot of sense. Sometimes there, I guess this is not to end on a theoretical note, but I guess sometimes you have something that's really good for one person, and then you have the kind of consensus being like, well, we don't really need that, and so then we kind of govern by the populace, which is just an interesting kind of result of it. And but I guess that's why people spin up nodes, and they kind of can go their own direction anyways.
Yep.
Well, Cassie, it was a pleasure talking to you, pleasure meeting you, and I'll stop recording here, and then but yeah, thanks so much for your time.
Yeah, likewise.